So you can talk on the phone, but go somewhere else to talk on the phone. All right, so number one, we're on review sheet 2 for our second semester exam, and we need to find all of the asymptotes of this guy. So the first thing we'll do is, I'm going to be just on this board, so if you guys want to move over here, because I'm taping this. So the first thing we're going to do is factor the denominator. So just regular factoring, nothing fancy or tricky about it. So in terms of asymptotes, remember we have vertical and horizontal. So I can look at the problem and say, look, x equals -5 and x equal -1 are my vertical asymptotes, because those are the things that make the denominator equal to 0, right? Yeah. Now, my horizontal asymptote I get by comparing the fraction. Now, the first thing you should notice is this is an x squared and this is not.
So it's a 0.
So the asymptote, the horizontal asymptote, is y equals 0. Anytime you go to compare and the one on the bottom is bigger, then you know your asymptote is going to be at 0. Number 2, find the remainder. Well, I'm going to divide, right? That's what remainders mean, divide. What is going to go in the box?
2.
+2. So 2, oh, watch it, watch it, watch it. Did you notice?
If there's not a 4.
There's not a 4, so I have to put a 0 in there. Looks like there's everything else, so I'm okay. But you have to pay attention when you go to write down your dividend. Those numbers are called the dividend. When you go to write that down, you got to make sure that every power is there. When you have one that's missing, you have to put in a 0. Okay, so here we go. So drop this straight down. Then 2 times 2, add them. 2 times 4, add them. 2 times 10, 2 times 11, and 2 times 23. So the answer is 47. The question is, what's the remainder? So the remainder is just this last number, right? That's the remainder. Okay, find the Y-intercept. Now there are a couple of these, and I think there may even be another one somewhere else on the test. How do we find Y-intercepts no matter what the equation looks like? No matter what it looks like, how do we find a Y-intercept? We let 0 be, or x be 0. We plug 0 in. So this is going to be a 0. Now, what happens when I raise something to the 0th power?
It becomes 1.
It becomes 1. So I have 80 over 1 plus 4 times 1,
4.
which is 80 over 1 plus 4, which is 80 over 5, oops, 5, which is 16. So the Y-intercept is 16. So one more time, no matter what the equation looks like, how do I find a Y-intercept? I let x be 0. So when I look at the next one here, the Y-intercept, so I'm going to let x be 0. So I'm just going to put zeros in there for those x's. So 0 minus 1 squared is 1. And 0 plus 3 is 3, so that Y-intercept is just 3. So one more time, even though I already said that, how do we find a Y-intercept? We let x be 0. Alrighty, so now we've got an absolute value equation. Now, what are you going to do first? Add 3. You're going to add that 3. We want to try to get the absolute value all by itself. We call that isolating the absolute value. We want to get it all by itself. Now, at this point, you got some options, but most of you seem to prefer the option where you split it into 2 equations. So one equation will just be 2x minus 4 equals 9. The other equation will be 2x minus 4 equals negative 9. So when we have an absolute value equation, we're going to take this guy right here, the thing in the absolute value, we're going to set it equal to that number, and then we're going to set it equal to the negative of that number. Then we'll just solve it like a regular equation. So if I add 4, divide by 2, add 4, divide by 2. So how many answers did I get to my absolute value problem?
1.
How many answers did I get? 2. I should get 2 answers when I do an absolute value. Yes, you have to find
I thought
both.
you said you can't have a negative.
No, the answer won't come out negative, but if you put a negative 5/2 here, that equals 9. So yeah, the answer, like this number right here, the 9 won't be negative, but you can plug a negative in. You can let x be a negative. It just gets changed to a positive when it comes out. All right, number 5. Gosh, and then we're done with the front of the page already. Now, our job is to get x by itself, right? So we need to start getting x by itself. So what do we need to get rid of in here? The 1. So we're going to subtract a 1 on this side, subtract a 1 there, and subtract a 1 on this side. So negative 5 is less than 2x is less than or equal to 14. I had to get rid of this 1 right here. But I had to subtract it on this side and on this side. Now what do I need to get rid of? The 2, so I'm going to divide everything by 2 in order to get rid of that. So negative 5/2 is less than x is less than or equal to 7. Now, quick comment, this is going to be a multiple choice question. So certainly that is a fine answer, but it may be written in interval notation in the answer choices. So make sure that you remember open intervals, not equal to's, are parentheses, and or equal to's, closed intervals, are brackets. These are exactly the same thing. So whichever one's there is the one you're going to use. All right, now we're solving. The directions say solve. You know how to do this problem. To solve this problem, it's a quadratic. How could I solve it? Factoring is an option. I don't think this one factors. If it does factor, that's an option. It's a fine option. But this one doesn't. So what am I going to need to do? Quadratic formula. So x equals, gotta know the quadratic formula. I'm not giving it to you. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's 3 plus or minus what? The square root of, watch it, you got 2 negatives, right? So that's going to become 29. Does that reduce in any way? No. So that's it, you're done. Be multiple choice, you'll check for that answer. There it is. Y equals x minus 2 over x plus 7. And we want to know the domain. Right? there are two things to worry about with domains. Everybody remember what the two things are?
You want it to equal a non-real number?
Yeah, and the only way it's going to equal a non-real number, Max, is if you have a radical, whatever's under the radical has to be positive. I don't have a radical, so I don't need to worry about that one. What's the other one? There's two things, and that's one of them. What's the other one? Can't have a 0 in the bottom. So what's going to make that 0? What would make that denominator a 0? -7. So x is not equal to -7. That's your domain. That means you can have any number in the whole wide world except -7. Now here's the kicker. It probably isn't going to be written like that in the answers. If we're talking about every number except -7, we're talking about that, right? Everything except -7. So it might be written like this. That is another way of describing every number except -7. See how those are parentheses? That means there's an open dot. That means it's not included. That's just another way of saying everything except -7. All right, now we've got number 8. So the function is this, and you are asked to find f of x minus 2. Okay? How do we do that? How do we find f of x minus 2?
X minus 2 or x's.
Yeah. See how instead of x, there's an x minus 2? See, in the parentheses? That means every time I see an x, I'm going to put in x minus 2. So 2x minus 2 squared plus 7x minus 2 plus 1. Now what? I have to simplify that. That will not be the answer. What do I need to do? FOIL. So 2 times x minus 2, x minus 2, plus the rest of this. I can go ahead and distribute that, but I need to FOIL here. So I'll just keep the 2 for a minute and do my foiling. X squared minus 2x minus 2x plus 4. Everybody in the room knows how to FOIL. First, outside, inside, last. Plus 7x minus 13 if I add those together. So 2x squared minus 4x minus 4x plus 8 plus 7x minus 13, collecting like terms, 2x squared
I have a question.
minus x, yep.
So why wouldn't you just okay, never mind, I got lost.
When I have the square, PEMDAS says I do the exponent first and then I do the multiply. So I have to do the squaring first and then I do the multiply.
Okay.
Now I could have added like terms here. I went ahead and did it at the end, but you could certainly combine like terms at that point. I think I added right. I think I had the right answer. Okay, that took a lot of space. All right, number 9. Two functions, f and g. And I am to find f of g of x. Well, believe it or not, this problem is almost identical to that one. They're very, very similar. Because what is this one saying? This one's saying take g of x and plug it into f. So this is g of x. G of x is supposed to get plugged into f. So that means this is going to go in for all of the x's in the f function. Put g into f. So if I put this in here, I'm gonna have x plus 5 squared minus 2x plus 5 plus 3. Isn't that just like what we just did?
Yes.
So this will be a FOIL. Minus 2x minus 10 plus 3. Please be careful on your distributive here that you are carrying that negative through. So x squared plus 5x plus 5x plus 25. So I don't know what you got. I got x squared plus 8x plus 18. Does that look okay? And by the way, that's the answer. Don't do anything to it. Stop. Just stop. The question wants to know what happens when you plug G into F. And when you plug G into F, that's what happens. Okay, what's next? Graph. What does an x squared equation look like?
Probably.
A parabola. So tell me about this parabola. This is going to be a parabola. It opens downward because of the negative. It shifted 2 units left and 1 unit down. So 2 units left and 1 unit down means its vertex is at -2, -1. And you said it opened down. Done. That's all you have to do. That's it. Now this is also a parabola. How do I know? It's a squared, so it's a parabola. But it is not in this form. So when they're in this form, you can look at it and say, hey, the vertex is at -2, -1. When they're in that form, you have to do a little work. What's the little formula we have to find the vertex? X equals -b over 2a. X equals -b over 2a. So in this problem, -b would be -6. 2a would be +6. So -1. Now, is that the vertex? No, that is the x part of the vertex.
So you just plug in -1.
So now we come back to the equation, see where it says y equals? I want to know what y equals. So I'll put in -1. So 3 times -1 squared, 6 times -1 minus 1. So what's 3 times -1 squared? That would be -1, always square first,
That'd be 3.
so that'd just be 3. Minus 6, minus 1. So 3 minus 6, minus 1, -4. So there's your vertex. There is your vertex. Whew, here we are on the back page. Fine.
Are you gonna give us the vertex formula?
I'm not giving you any formula.
Okay.
Yeah.
Trying to set us up.
I'm trying to set you up for failure. That's why I'm here on a Sunday afternoon. Because I want you all to fail.
Sounds about right.
All right. What equation would show the following transformations applied to y equals x squared? So we're starting with a parabola. And we want to have an equation that shifts you horizontally left 2. So what would I have to do to this equation to get a left 2 shift? Right now, it's sitting right here.
X plus 2.
It has to be x plus 2 squared. Isn't that what's going to shift it to the left?
Yeah.
A vertical stretch by 3. So in other words, I want to multiply the height. I want to make it a taller, skinnier parabola. Put a 3 in front of it. That's a vertical stretch.
And a subtraction.
vertical shift down 1. -1. That's it. Done. That's your equation. It does what you wanted it to do. Okay, so now we've got a picture. And got a point right here. Point right here. Point right here. And point right here. Okay. Alright, so we want to describe, or write down, the intervals where this function is decreasing. Decreasing means moving down, right? So if I start drawing from left to right, aren't I going down? Till I get to here, right? So what are the x values? I'm talking about going left to right. What are the x values? Where did I start going down? What x
4.
value? -4? Where did I stop going down? What x value? -1. So there's your first interval where you're going down. From -4 to -1, you are going down. I'm looking at the x values. Why am I looking at the x's? Because I'm moving left to right. Those are the x values. Now, am I going down here? Nope. But wait a minute. I start going down again right here, right? So what are those x values? 1, 2, 4. Those are the intervals where I am decreasing. I'm decreasing. My pencil is going down. Decreasing means your pencil is moving down. Okay, next. Got an equation that's all nicely factored for you. And we're going to go ahead and graph this thing, and then we'll worry about the questions. Let's get it graphed. What do I start with when I have something like this that I want to graph? What's the first thing I do? Put some dots on there. And where are those dots going to go? -1 and 3. Now, this is a cubic function, right? There's 3 x's up there. And I know that cubic functions start down and end up. So I'm going to start down here. And then when I get to that point, I have 3 options. My options are go right through, bounce off, or squiggle through. That dot came from this factor, right? So when there's a square, that guy bounces off. Now, what does it do when it gets to the 3? Just goes straight through. So there is a picture of the graph. So now we can answer the questions. Find the X-intercepts. Well, that's where you started. These are the X-intercepts, aren't they? So your X-intercepts are -1 and 3. The dots are your X-intercepts. At what point does the curve just touch or bounce or is tangent to? Is tangent to means bounces off. Where does it bounce off? At -1. Now, I drew that just to jog your memory, but could you tell by looking at the equation that it's going to bounce at -1? Yeah, because you see the squared factor. So the graph wasn't really necessary. I just did it to help us see what was going on. Okay, find the inverse. So here's the original equation. All right, Maddie, you know this because we just did it earlier. How do we find the inverse? What do we do?
Do x equals -2y.
So she says switch the variables. To find the inverse, we switch the variables. Then what?
And then we solve.
Yeah, y by itself. We solve for y, get y by itself. So we'll start by moving the 3 over, right? And then divide by -2. Rewrite in exponent form. And you're thinking, oh, that doesn't sound familiar to me, Mrs. Ford. How about loop-de-loo? That's what you're doing. You're writing this thing with an exponent instead of with a logarithm. So what's the base? So e to the x equals 16. Done. There it is. Is this an exponent form? Yeah. Does it have an exponent? Yeah. That's it. That's all that problem means. Loop-de-loo it. So there's no more logarithm. Now it's an exponent. Now, another logarithm question. We want to write this as one logarithm. So it's ln something. And the something is going to be a combination of the 8, the x, and the y. Agreed? So Monty says 8 times x over y. She right?
No.
No.
Not quite. What she wrote is right. It just isn't done yet. What did she leave out?
Squared x.
This guy has to go as an exponent on the x. Right? You're flying. All right, now we're going to sketch. So we just did this one. We are going to do the exact same problem. Okay, the difference is this one's not factored. So what are you going to do first? You're going to factor it. So you're going to pull out an x. And then you're going to notice what? You have the difference of squares, which you have to know how to factor the difference of squares, x minus 3, x plus 3. Now we're right back to where we were a minute ago. Is this one going to have any bounce off points? No, because none of these are squared. Where do the dots go? These are called the X-Intercepts. Where do they go? 0, positive 3, and negative 3. Remember, when there's a plane X, the dot is at 0. Now, this is a cube, clearly. It's a cube. How do cubes behave? Start down and up. So here we go. You told me there's no bounce off points, so I'm just going to pass right through them. Is that all right? There's your sketch. It's that easy. That easy. This is very recent material. Everybody should get this one right. Here we go. 4 to the second equals 3x plus 1. Oh my gosh, these problems all start to look alike. So 15 equals 3x and x equals 5. 1 logarithm, loop-de-loo. 1 logarithm, loop-de-loo. Max, 1 logarithm, loop-de-loo, right?
Mm-hmm.
Okay. How do we do that? That's from a long time ago. How do we do it? Distribute FOIL. Yeah, to distribute the property of FOIL. So first would be 10. Outs would be 8i. ends would be negative 15i, and lasts would be negative 12i squared. Now, what do we have to remember about I squared?
Just one.
It's negative 1. So a negative 12i squared would actually be plus 12. And these two are both i's, so they can add together as negative 7. And then we have a 10 and a 12 that can go together as 22 minus 7i. One property question. We don't want to miss it. U plus V plus W, whoops, equals V plus U plus W. Okay, so let's look at the problem. Don't just say something because you see parentheses. It's commutative. And the reason that it's commutative is because these guys commuted. They moved. They switched spots. It was U plus V here, but it's V plus U here. Did I change the parentheses? No, that is commutative. That's commutative. I switched. As I copy this down to save myself some room and some writing, I'm going to go ahead and factor this last denominator. You should always factor any denominator that factors. Obviously this one doesn't factor and that one doesn't factor, but this one does. So I am going to factor every denominator that factors. Now what am I going to do? With my purple marker, I'm going to do what? Multiply everything by x plus 1, x minus 2, x plus 1, x minus 2, x plus 1, x minus 2. Now, even though it's multiple choice and some of it will be done on Scantron, you're still going to be writing in your answer, or writing in the test booklet itself, just like you're doing now. The test is like a packet like this. You're going to write right in it. Bring a colored pencil if it helps you to keep things straight. So we're going to cross these off. So we have x minus 2, plus 3, x plus 1, equal to 5. Ready? Righto? So now we'll do some distributive. X squared minus 2x, 3x plus 3. No, actually I'm not going to subtract 3. I'm actually going to get it set equal to 0. It's a quadratic equation, and whenever I have a quadratic equation, I want to have it set equal to 0. Because what am I going to do with my quadratic equation? I'm either going to factor it or I'm going to use the quadratic formula. So either way, I need to have it set equal to 0, right? So here we go. What do you think? Does that one factor? It does. Do I have to factor? No. If you want to use the quadratic formula, go right ahead. But this one does factor x plus 2 minus 1. So my answers are negative 2 or positive 1. Beep, beep, beep. Extraneous root radar. This kind of problem can have an extraneous root. What happens if but it doesn't, because 1 doesn't make that 0 and negative 2 doesn't make that 0. So the answers are both of those. Do we sometimes have extraneous roots?
Yes.
So double check it. But in this case, they're both going to be answers. Oh my golly, we are already on to the calculator part. So what will happen on your exam day is, after you just did everything you just did, you'll turn that in, just like you did your logarithm test, and then you'll get your calculator out and you'll start in on the green. Alpha period wanted it to the green, so I ran it off on green.
Why did they get a choice? Did nobody else get
Because I like them better.
Oh no, you like E better.
All right, so here we go. They were first, so whoever was first got asked. All right, so here we go. Now we're using our calculator. We're allowed to do all of this on our calculator. Boy, we're just about done already. Here we go. What are you going to do with this problem?
Synthetic division. I don't know. I just put something. Oh yes, synthetic division.
Oh, well, not first. First it says list the PRRs. Okay, we're going to list the PRRs. So, who remembers how we find the PRRs? Factors of plus or minus, factors of 27, which would be 27, 9, 3, and 1, over factors of 3, which are 3 and 1. So take all the combinations. So we have 27, 9, 3, and 1, because 27 over 1, 9 over 1, 3 over 1, 1 over 1. Now do them all over 3. So 27 over 3 is 9. It's already in the list. 9 over 3 is 3. 3 over 3 is 1. But what about 1 over 3? It's not in the list yet. So there are the numbers in the list. Plus or minus all of those numbers. So each of these goes over 1. And then each of these goes over 3. But you only put them in the list once if you get repeats, which you usually get some repeats. Those are the PRRs. So that's the answer to part A. Didn't need a calculator for that. It's fine. Just list them. Now, find the solutions algebraically. So in other words, we need to solve this thing. We need to set it equal to 0 and solve it. Take a look at it. What do you think?
Synthetic division.
You can use synthetic division for sure. Or you would pick one of these.
What's that thing called?
You would pick one of these and divide it and hope that what happens? You get 0. So one option you have is to pick some numbers one at a time, pick a number out of this list. I would probably start with like 1 or -1, and you divide them out until you get a 0. Now another option you have on this problem, and you also, bless you, you also had this option on the other review sheet. If you look at your problem, it actually factors by grouping. So if it's easier for you to factor by grouping, you would just take, 3x squared, x minus 1, plus 27, x minus 1. Factor by grouping. So you have a match, x minus 1, and then we have 3x squared plus 27 left. Now, does that factor? You actually can take a 3 out, right? I'm going to put it out here in front. Does that factor? Oh.
No, it doesn't.
No, it doesn't. It would if this were a minus, but that doesn't factor. So now I'm going to take each of my parentheses and set them equal to 0, and I'm going to solve. So it looks like x equals 1, when x squared equals negative 9
3i.
plus or minus 3i. Very good, Max. I'm square rooting. When I square root, it's plus or minus. Plus or minus the square root of negative 9 is 3i. If you had done this using synthetic division, remember I told you to try 1 and negative 1 first? So let's see, if we tried 1, if we decided, you don't do both, okay? So if you've already done that, you're done. But if you decided to do synthetic division first, you get 3x squared plus 27. See that? And then you're going to be right back to where we were over here if you did synthetic division. So there's the 1 that we got. And then you're going to solve that and get the other stuff that we got. You can always use synthetic division. Always. Hmm?
You put negative 27, negative 27 when it's supposed to be 27.
No.
Thank you, Max. All right, number 24. This is very recent material. Look at that equation. You are solving for x. Where is x? Exponent. When x is the exponent, you need to use logarithms. Since the question is an E problem, I'll ln both sides. Right? Now what happens right here? So 3x plus 1 equals ln 10. Now remember, you're solving for x. So don't we need to subtract 1 and divide by 3? So I'm going to take ln 10 on my calculator. I have a number. ln 10 is just a number. I'll minus 1 from it and divide by 3. Did you get 0.4342? No, do it again.
Wait,
ln 10.
Do I need to close parentheses?
Yes, of course you need to close the parentheses. ln 10 minus 1 equals divided by 3. ln 10 equals minus 1 equals divided by 3 equals. Now a minute ago I said I wasn't going to give you any formulas. Right before I made the copies, I just totally wussed out and put the compound formulas on the front of the calculator part of the test. So that formula is on there.
Miss Fred, I have a question. In your email it said that the bonus problem is not going to be like any problem that we went over.
No, we've gone over it, but it was a homework problem, not, it was not on the packet. No. Okay, here we go. To the nearest dollar, find the amount you would have from investing $1,200 at 3.1% compounded monthly for 10 years. So, find the amount if you invested $1,200 at 3.1 interest rate, compounded monthly for 10 years. You need to be able to get all of the numbers into the right spots. So the question is really asking how much will I have at the end, right?
Mm-hmm.
So you remember, because I've said this so many times, let's take care of that, make it a 120. No sense having a double exponent, it just means more parentheses. This is just a plug-in problem, right? I don't need logarithms, I don't need to do anything fancy, I'll type exactly what I wrote. So 1,200 parentheses, 1 plus 0.031 divided by 12, close parentheses, raised to the 120th. And you're gonna have 1635.46. That's how much money you're gonna have at the end of 10 years. All right, so the other formula I'm gonna give you is this one. And everybody knows that's the formula that goes with this problem, right? Number 26?
Yep.
So it says find the growth constant for a strain of bacteria that grows from 154 into 912 in 3.5 hours. Now this one is not as easy as this one. This one was just a type-in problem. Where's the variable in this guy? Exponent. I know I'm going to need logarithms. But if you do logarithms right now, you're going to miss the problem because what has to happen first? We've got to divide by 154. So 912 divided by 154 equals e to the 3.5r.
You do ln.
Now I can ln. And this right here is gone.
You make 3.5r.
So ln 912 over 154 equals 3.5r. So I'm going to type this into my calculator and then divide it by 3.5. And that's going to give me r. So ln 912 divided by 154 divided by 3.5. Oh my goodness. Did you get 0.5082?
Yeah.
Why am I a little startled by that?
I'm not really sure.
That's a big one. That's a 50% growth rate, right? That's a 50% growth rate. Those guys are growing fast. All right, 27. This is the question, and if you miss it, I will publicly humiliate you. We're not going to miss this question. Right? This one we're not missing. This is a first year. We just had open gym, helping all these freshmen with their review packets. Every one of those freshman review packets had that question on it. So we can do this.
X2.
Somebody else do it.
No.
What?
No.
You find slopes.
We find the slope.
Jordan, what?
And the slope.
This is just like class, bro.
And the slope is 8 minus 6 over 4 minus 5. No, you did x's on top. It's y's on top, Jordan. Y's on top. So it's 8 minus 6 over 4 minus 5. So my slope is -2. Right? And then you decide how you're doing it, whether you're doing point slope or slope intercept, I don't care. But you pick a point and you use that slope and you go for it. So 6 equals -2 times 5 plus b. If you're doing y equals mx plus b. So 6 equals -10 plus b. B is 16. Or you can do y minus 6 equals -2x minus 5. Either way, you get exactly the same answer. You don't care how you do it, but that's the answer you have to come up with. Honestly, there is no reason for you to miss that. Next, another one you shouldn't be missing. I go to the store and I'm gonna buy something that's $83.20. But that isn't how much I am paying, because there is a 20% discount. So I am gonna take off 20%.
So it's gonna be 80.
And then I'm gonna add a 7% tax. Now, if I am taking off 20, then I am gonna multiply by 0.80. 100 minus 20. And then if I'm adding on 7, I'm gonna multiply by 1.07. So I type it into my calculator, 8320 times 0.8 times 1.07. I'm gonna pay $71.22 for this item. Remember, this is 100 minus 20, and this is 100 plus 7. Number 29. What's the general formula here?
Parentheses.
Amount times percent plus amount times percent equals amount times percent. Now Monty doesn't even bother with the words. We have done so many of these problems. She just knows it's going to be a couple of parentheses plus a couple more equal to a couple more, right?
Right.
That's what it is, guys. We have done so many of these. So now we'll fill in all of our percentages from the problem.
From 0.08.
So yeah, watch it. 8% is 0.08. Don't put 0.8, it's 0.08. We got 100 gallons of 90%, and we're going to end up with a 65%. So there are my percentages, plus the 100 that was in there, 100 gallons of 90%. How much
X plus 100.
to end up with 100 plus X or X plus 100? That's exactly right.
But don't you, when you have to subtract, it's 100 minus X,
Yep.
right? Okay, so we're just gonna say 100.
Okay. So I'm just multiplying together. You will have a calculator, so certainly if you are concerned about the arithmetic, you'll have a calculator. Now I'm gonna put all the X's on the same side. So I'm gonna subtract 0.08X over to here. Watch the decimal, please. So that will be 0.57X. Then I'll subtract 65. I'm just solving an equation like you've done a million times. And then I'll have to divide. So this is where I really need my calculator.
For these ones, you want us to get decimals?
Divided by 0.57. I got 43.8. I don't know how we're rounding. I'll just say 86. What is it? Gallons? So whatever the directions say on the test, you want to round that way. Okay, next. We gotta simplify this thing. All right, here we go. Let's start inside. Not much to do with the 4 and the 3, whoops, except put them in the right spots. What about the X's? Move the 3 up. Remember, they only move if they're negative. So the 3 are going up, and it's going to be X to the 8. It's got the same issue with the y's, only they're coming down, so do y to the 9th and z to the 8th. And you're still squaring it. Anything that's negative moves. If it's not negative, don't move it. Max, you okay?
Yeah, I just solved it.
Oh, okay, you're done already. Let's see if you got it right.
Okay.
Or let's see if I got it right. How about that?
Alright,
All right, so here we go. I'm going to square everything now. So I have 16 x to the 16th. Remember, double exponent multiplies z to the 16th. 9 y to the 18th. Is that what you got, Max? Good deal. All right, believe it or not, folks, one more problem. Of course, it's a big one. But the good news is everybody knows how to do it. So here we go. It's a 20 by 16 piece of paper. Remember, the exam question is going to ask the exact same questions. It's just going to be a different size paper. So when it says, what is the equation for the volume of the box? These are the x's getting cut out from the corners. What is your equation going to be? Length times width times height. So what's it going to be? 20 minus 2x. 16 minus 2x, and x. You have a piece of paper, and you are cutting an x from each side of it. That's 2 x's. Cut away. 16 minus 2x. There is your equation for the volume. So that's the answer to A. Now, Zion, we're not missing that problem, right? Because all that's going to be different is these two numbers are going to be something else. But everything else stays the same. What is the domain? The domain never changes either except for one number. The domain is always 0 less than x less than something. The sides of the paper are 16 and 20. What's the smallest one? What's half of that? That's the number that goes here every single time. I don't even know how else to say it. I've said it so many times. 0 to 8. 0 to half the smallest dimension. Now, this is a change. This is a common problem. This is a problem everybody's going to have on the exam. So I had to change it a little bit because other teachers didn't want to put this on. So you will not be writing down, you won't actually physically be writing down the viewing window. You won't be telling me, I mean, you can write it down, but it's not for points. You put down X min, X max, Y min, Y max. This is up to you. You need to know it, though, to put it in your calculator. But you won't necessarily be writing it down. The other teachers thought it was too easy and didn't want to give points for it. So you have to know it. You have to know it. Because you got to put it in your calculator, right? So the good news is you've already written down X min and X max. It's already written down. Y min is always 0. What do we do for Y max? We pick a number. I'm looking over here. This is a pretty big piece of paper. I think I'll start with 500. Now, do I know if 500 is going to work? I have no clue. I'm going to try it. So I'm going to go to my calculator, and I'm going to set my window at 0 to 8 and 0 to 500. Then I'm going to type in this equation. Now, caution, you may already have an equation like this in there if you worked with me in class the other day or if you've been working on your own. you gotta change that equation, kids. You gotta put in the right equation. So I gotta change mine to 20 minus 2x, 16 minus 2x, and x. And I'm gonna press graph. Hey, that worked out pretty well. Why do I say it worked out pretty well? What means it worked out pretty well? What happens?
Because it all fits in.
It all fits in. That's a good way of thinking about it. It all fits in. This is the point I'm interested in because the problem says maximize the volume. Maximize the volume. Right? So I'll second calc. Go down to maximum. Left bound. Right bound. Yes. And that point is 2.94, comma, 420.11. What's the matter, Max?
No, it's just like I did this like 2 minutes like ahead of you guys, and I didn't even know if I was gonna get it right, but I actually got it.
Right. Amazing. All right, now let's make sure we answer the question. What size corners should be cut out? The corners are the X's, right? So the answer is 2.94 inches. 2.94 inches. What would you put if it said find the maximum volume? 420.11 cubic inches, right? Gang, 5:17, 1 hour and 2 minutes. We just went through the whole exam. You are